Today we are going to be looking at how to name ionic compounds. And then we'll let this get started here. Okay. And as a quick review, ionic compounds are made of metals and nonmetals. So an example of that would be NaCl. The metal, which is sodium in this case, is also known as a cation, which means it has a positive charge. And the nonmetal, chlorine, is considered an anion, which means it has a negative charge. So when you name an ionic compound, it's a pretty simple process. The first thing you do is the cation, the first part of the compound, you use just the regular old element name. So for example, Na is sodium. And then what you do with the anion is that you take that element name, you cut off the ending, and you add IDE suffix. So chlorine would become chloride. And then you just put those two pieces together. And so in this case, it's sodium chloride. So if you would, go ahead and I want you to pause the screen and I want you to look at the 4 examples that are up there on the screen. Okay, the answer for the first one for Ki would be potassium iodide, MgO, magnesium oxide, CaI2 would be calcium iodide, and Li3N is lithium nitride. Now, how do we go about writing the formula? So we talked about naming them, so how do we write the formulas? The most important thing when it comes to naming an ionic compound is the understanding that the cation side and the anion side have to add up to be equal to 0. Now, down below is a picture of the periodic table, and we've already gone over this in class, and you should have this stuff written on your periodic table, but if you don't, again, pause the screen, get out your periodic table, and make sure that those charges that are at the top of the groups have been properly recorded on your chart. So here's an example, strontium oxide. So the first thing that I did is I took the formula for strontium, I looked on my periodic table, and I saw that it had a +2 charge. Oxide comes from the element oxygen, so I put a -2 charge on it. And then this one naturally balances itself out. Now, what do you do if they don't add up to 0 right away? So let's go ahead and take a look at the video clip here. So the example we have is aluminum oxide. And the charge that is on the periodic table are written there. So we use what's called a crisscross method, where the charge of each compound becomes the subscript of the opposite compound. So Al2O3. Another example is sodium nitride. Sodium has a +1 charge, nitrogen -3. I use that crisscross method. The 1 comes down and the 3 comes down. So essentially what we're doing is we're adding more atoms in order to get that to balance out. Okay, what do we do if we have transition metals? Transition metals, as we've talked about many times, are the elements that fall between the 2 goalposts of the periodic table. There is a link here that will show you the transition metals. Again, if that's not indicated on your chart, please follow that link and you can see that. Oops, we'll let that pop up. But here for this one, we have iron 3 oxide. Oops, I went too far. We have iron, Fe2O3 is iron 3 oxide. That 3 in the parentheses there represents the charge of iron. So how do you figure out the charge of iron? My apologies, this is taking a while to load. is. So Fe2O3, so you can see that 3 that was the subscript on oxygen becomes the charge on iron. So we are uncrisscrossing. Okay, here's a couple of other examples with writing formulas. So for copper 1 sulfide, the formula should be Cu2S, and that's because copper has a +1 charge and sulfur is a -2 charge. And again, we'll take a look at the work here. Okay, so copper 1 sulfide. Copper has the +1 charge. Sulfur has a -2 charge. Got that right off the periodic table. Use the crisscross rule, bring the 2 down, and there's your proper formula. For gold 3 bromide, gold has a +3 charge. Bromide comes from bromine, which has a -1, again, right off the chart. Use your crisscross rule, bring that down. And then manganese 2 phosphide. Manganese has a +2 charge. Phosphorus, -3 from the periodic table. Bring the charges down. Okay, let's say if we're using something called a polyatomic ion, you have been asked and you have been quizzed on what your polyatomic ions are. So those should be part of your working knowledge. But here's some examples on how you name with polyatomic ions. So there's lead, has a +4 charge. Sulfate is SO4, which we've learned has a -2 charge. Crisscross, bring the 4 down and the 2 down. This is a case where those subscripts can be reduced because atoms combine in lowest whole number form. Next, we have tin, which has a +2 charge. Formula for chlorate, ClO3 with a -1 charge. Crisscross, bring those down. Cobalt 3 nitrate. Bring the 3 down. And then lead 3 hydroxide. And bring the 3 down. Okay, when naming with ionic compounds, it is most important that you first, when you look at the compound, you need to start to ask yourself if you have a transition metal. Because if you have a transition metal, that is going to indicate to you that you are going to have to use that parentheses. All right, this should help get us started.